Hey UK level students, welcome back to AQA Academy. If you are doing OCR, Edexcel, AQA or CIE Maths, this series is for you. We are doing differentiation and we have made some videos on it as well. And in today's video, we are doing differentiation of implicit functions and parametric equations. So I'm starting with implicit functions. There are different ways of categorizing functions, but in this context, functions are divided into two types: explicit functions and implicit functions. So if I talk about the explicit functions, in this function, the y is equals to fx. When I'm writing y is equals to fx, in explicit function, the dependent variable y is on one side of the equation and the independent variable x is on to the other side of the equation, like this one. Y is equals to x squared minus x plus 2, or y plus x squared is equals to 3. In that case, what I can do, I can shift x squared onto the right hand side and make y the subject. And in this way, I can make y the subject. I am able to separate out the variable y on one side and variable or x on another side. Such functions are called explicit functions, and we have done the differentiation of these explicit functions so far. But today we are doing implicit functions. So let me understand what it is. Take an example of this: x squared y plus x cubed y squared plus 4x equals y. If I want to make, or if I try to make y as subject, can I, let's see, bringing all y onto the one side like this. Now, even if I take y as common, remaining is x squared plus x cubed y minus 1 plus 4x. Bring this on to the left hand side. This will be y times x squared plus x cubed y minus 1 is equals to minus 4x. And in order to make y the subject, I'll do this one. But you can clearly see on right hand side, still I have one y. I'm not able to separate it out. And that function is called implicit functions. So today we are doing the differentiation of these implicit functions. So for implicit functions, what you have to do, you just have to differentiate them like simultaneously, which means if I'm doing, let me take an example, simple one: y squared plus x squared plus 2x is equals to minus y. Let's see. So when we are differentiating y squared, we are not treating it as a constant because y and x both are variable. So in that case, I have to differentiate variable y exactly how we know to differentiate x. So in this case, y squared is, if I'm differentiating x squared, it will become 2x. Similarly, if I'm differentiating y squared using the same formula, it will become 2y. Only difference is with 2y, I'll use 2y over dy over dx. So with 2y, I will write dy over dx. Then differentiating x as it is, 2x, here 2, and y, differentiation of negative y is negative 1. But again, if I'm differentiating y, I have to write dy over dx. Now bringing all dy over dx on one side and other variables on another side. So that means I will bring it here. This will become 2y plus 1 times dy over dx. I have taken out dy over dx as common. And this will be negative 2x, negative 2 on right hand side. Finally, this will become dy over dx. And this will be, if I take out negative 2 as common, remaining is x plus 1. And dividing it with 2y plus 1, and this is how we can find the final answer. Well, now let me explain you why I have written dy over dx. I did nothing. Actually, I have applied the chain rule. So chain rule is, let me show you. Say for example, we have already done the chain rule. So if I'm finding dy over dx and if I'm substituting any other function as t, so it will become dy over dt times dt over dx. That's what our chain rule is, and same I'm applying it here. This is our function y squared. Let's say this is equals to u. Generally, y is equals to f of x, right? So we have two variables depending. Your y is a dependent variable and x is independent variable. Similarly, this function can be written as u is equals to y squared, and now I am differentiating this u with respect to x. That means du over dx I have to differentiate for y squared. But y squared is already a variable and u is a variable, and we are differentiating it with respect to the third variable. So I have to apply the chain rule. This can be written as du over dy times dy over dx. It's exactly the same. There our function was y is equals to x to the power of e to the power of x, something like this, say for example. And what we were doing, we were trying to substitute e to the power of x as u. Suppose we have done, or let me take a much more simpler example. Let's say y is equals to, let's say e to the power of t squared. So we don't know the differentiation of e to the power of t squared. So for that, I have substituted u with t squared. But now I have introduced a third variable, and I have to differentiate this one in order to get dy over dx. So there we apply dy over dx, and this will become dy over dt times, dy over dt in this case, dy over dt, and this will become dy over du and du over dt. In this way, we'll be able to find dy over dt. So this happens when we have a third variable. Similarly here as well, we have y squared, but we have introduced a third variable which is u, and actually we are trying to find the differentiation of du with respect to dx, and that's why I have applied the chain rule. Now differentiating du over dy, that means this one will give me what? 2y, and this will remain as it is. And that's why whenever we are differentiating any y function, we always write dy over dx along with it. So we differentiate y exactly how we differentiate x, but at the same time we multiply it with dy over dx because of the chain rule. Now see this example, we have to differentiate this one. So since we have y and x squared together, we have to treat them as two different variables when we are different two functions when we are multiplying, and obviously we'll be using product rule in this case. So let me differentiate first function y, which will become 1, and I have to write dy over dx along with it, plus differentiating x, 2x, and writing y as it is, plus differentiating y squared, 2y, and writing dy over dx, and sine y, again it's a function for y, there's a variable y, so it will become cos y, but we have to introduce dy over dx along with it, is equals to differentiation of y is 1 and writing dy over dx. Now bringing all dy over dx onto the one side, so 1 dy over dx plus 2y dy over dx plus cos y dy over dx, and I have brought this one from right hand side, will be minus dy over dx, and the only function which has no dy over dx is this one, 2xy. So bringing this onto the right hand side, minus 2xy. So this will become dy over dx. This will be cancelled out, obviously. This will become 0. And this will become 2y plus cos y and is equals to minus 2xy. And finally, dividing both the sides by 2y plus cos y, our final differentiation is dy over dx is minus 2xy over 2y plus cos y. And this is how you can differentiate any implicit function. Now, parametric equations. Parametric equations describe a curve using a third variable called a parameter. So instead of writing y in terms of x, like generally we have y is equals to sine x, y is equals to x squared plus 3, we write both x and y in terms of another third variable, let's say t. So say for example, your x is in this case equals to f of t. X is a function of t. Let's say x is equals to 3t minus 4 and y is equals to 4t squared plus t, and you can clearly see they both are in terms of a third variable. So what we have to do, we have to differentiate them separately in terms of t with respect to t. So dx over dt will become 3 obviously, and here dy over dt will become 8t plus 1. Now ultimately we have to differentiate and find dy over dx. So what I can do, dy over dx can be written as dy over dt times dt over dx. We have already found dy over dt, which is 8t plus 1. So this will be 8t plus 1 times, this is dx over dt, we need dt over dx, so just reciprocal it and we'll get 1 over 3. So my final answer for dy over dx will be 8t plus 1 over 3, and that will be your final answer. Obviously this answer will be in terms of t, but this is how you can connect them together. Now take an example, one more example. Let's say x is equals to sine t and y is equals to cos t, and we have to find dy over dx. So let me find dy over dt, differentiation of y with respect to t, this will be minus sine t, and dx over dt, this will be cos t. And finally dy over dx can be written as dy over dt times dt over dx. So dy over dt is what, this negative sine t times dt over dx. Dx over dt is cos t, so dt over dx, that is the reciprocal, will be 1 over cos t, and negative sine t over cos t is 10t. So finally this will become dy over dx as negative 10t. So that's it for today. This was all about the parametric equations and the implicit functions. These were the basic theory that is very important to do any sort of questions. Obviously the harder ones and A-level type questions we will be doing in the worksheets. So that's it for today. And also if you're looking for these free worksheets, they are available on our website, which is exacademy.com. And also if you're looking for one-on-one live online classes or group classes for levels, they are starting at just £8 per hour, and we have subject matter experts. We provide classes for almost all subjects. So to book a free demo, all you need to do is just email us at exactacademy@gmail.com and we'll coordinate. So that's it for today. Bye everyone. Take care.